Hearing is indeed one of our most vital senses. It allows us to gather a wealth of information about our surroundings just from sounds, whether it's the sound of a loved one's voice, the melody of a favorite song, or the warning of approaching car. Our sense of hearing plays a crucial role in how we interact with the world. Even the fetus can hear. Electrical recording of brain responses shows that fetuses can receive sound impulses as early as 25th week after conception, which is about 3.5 months before full-term birth. The ultrasound imaging revealed that while fetuses did not respond to auditory stimuli before 24 weeks after conception, by 28 weeks almost all fetuses clamped their eyelid in response to sound. Interestingly, the few fetuses who did not respond were later found to have hearing difficulties or were born deaf. It's fascinating that newborns can recognize a mother's voice very early on. Babies less than 4 days old could discriminate the mother's voices from strangers' voices. This was shown by the fact that the babies alter their sucking rhythms more readily when their own mother's voice served as reinforcer compared to when the reinforcer was the voice of a stranger. Interestingly, 4-day-old infants show no preference for their father's voice over that of a male stranger. This suggests that the familiarity with a mother's voice begins in the womb, as babies often hear their mother's voice more consistently. Fetuses can become familiar not only with a mother's voice, but also with specific sound pattern she produces. Pregnant women read aloud a story each day in the last 6 weeks of pregnancy. When tested at 3 days of age, their babies showed a preference for the familiar story over a new one, regardless of who was reading it. Fetuses might even show signals of recognizing their mother's voice by showing increased heart rates in response to recording of their mother's voice, but not to a similar recording of stranger voice. This indicates that the fetus can differentiate between familiar and unfamiliar voices even before birth. When it comes to sensitivity to sound, newborns are quite different from adults. For instance, while an adult can easily hear a whisper from about 1.4 meters, it's about 4.5 feet away, a newborn needs a sound closer to a normal conversational levels to hear it from the same distance. This difference might be partly due to fluid in the middle ear. Newborns are better at hearing low frequencies compared to high frequencies. However, by the time they reach 6 months of age, their ability to hear high frequencies improves significantly, matching that of adults. Sensitivity to sound continues to increase until around 10 years of age. These observations are supported by both behavioral studies and electrophysiological measures. For example, studies measuring infants' brainstem evoked potential show that infants initially have better sensitivity to low frequencies. By 6 months, their sensitivity across all frequencies, including high ones, reaches mature levels. This suggests that the development of sound sensitivity is more about the neural base of auditory processing rather than just the maturation of the inner ear structures. Did you know that even at just 4 months old, babies are already sensitive to various properties of music, such as contour and rhythm? Just like most adults, they prefer consonant musical inputs over dissonant ones. By the time they reach 6 months, they can pick out melodies even when the key or tempo changes. Interestingly, between the ages of 5 and 7, children start to show sensitivity to culture-specific scales and harmonies in musical structures. However, the sensitivity to culture-specific rhythms appear much earlier, around 7 months of age. Sound localization, or the ability to determine where a sound is coming from, relies heavily on detecting the time difference between when a sound reaches each ear. As children grow, their heads get larger, increasing the distance between their ears. This means that the same sound will produce a greater time difference in an older child compared to a younger one. Over the first year and a half of life, babies become increasingly skilled at distinguishing sounds in their environment. This improvement requires them to recalibrate their sound localization system to account for their growing heads. Essentially, they need to constantly adjust how they interpret sound cues to accurately locate the source of sounds. Even newborns show some ability to localize sounds, but this skill temporarily disappears around the second month of life. It reappears in more advanced form by the third or fourth month, become faster and more precise. This change suggests that different parts of the brain are involved as the child develops. This process of recalibration is not unique to sound localization. Babies face similar challenges in other areas, such as eye movement, head movement, reaching, and walking. Researchers are still exploring how this adjustment happens, but it's clear that neural maturation plays a significant role. Let's move on to the vision system. Our vision provides us with the most information about the world around us. We can see varies in brightness, color, and texture, and we can distinguish between hard and soft surfaces. We can identify dozens of objects and understand their functions, like light switches that can be flicked, containers that hold objects, shelves that contain books, and chairs that support people. But how do babies see the world? Can they interpret what they see? Newborns have a visual acuity of about 20/400 to 20/800. This means that what a newborn can see at 20 feet, a person with a normal vision, 20/20, can see from 400 to 800 feet away. By the time they reach 3 months of age, their visual acuity improves to around 20 hundredths. By 12 months, their vision approximates that of adults, although there is continued development into childhood. To put this into perspective, look at this picture of a face. Might look to infants at 1, 2, and 3 months of age from a distance of about 15 centimeters, which is 8 inches. The clarity and detail they perceive improve significantly over these few months. Visual accommodation is the automatic adjustment of the eye's lens to produce a focused image of an object. In newborns, the lens seems to be fixed for optimal focus at about 18 to 20 centimeters, which is roughly the distance between an infant and a mother's face during feeding. This led to the idea that evolution might have designed this to ensure that babies are attracted to the mother's face. In reality, the lenses of newborns are not fixed but the brain circuits responsible for accommodation are not mature enough to adjust focus based on distance. This means that variation in focal distance are relatively useless in the early weeks of life. Accommodation improves significantly between first and third months of age and becomes almost adult-like by 6 months. This development allows infants to see more clearly and adjust their focuses as they grow. Newborns can distinguish some colors, such as red from green and both red and green from white. This is because the red and green receptors in the eyes are functional from the birth. However, the blue receptor cells doesn't become functional until around 3 to 4 months of age. By the time infants reach 4 months, the ability to perceive color is similar to that of an adult. Infants are naturally attracted to displays with the highest age contrast they can see. Newborns primarily focus on high contrast ages such as where black and white meet and move their eyes back and forth over these edges. As babies grow older, they start to prefer more densely packed patterns. For example, 3-week-olds look longer at a 6x6 checkerboard than at a 12x12 or a 24x24 checkerboard. By 6 weeks, they prefer the intermediately complex display, and by 3 months, they are most interested in the most complex display. When babies move their eyes over edges, they activate the cells in the visual areas of the brain. The strongest brain activity occurs when the baby looks straight at the edges, and the more detail they can see, the stronger the activation. This visual activity in early infancy reflects a biological agenda to keep brain cells firing at the high level. This activity helps stabilize the necessary connection in the brain while inactive pathways deteriorate. Interestingly, this agenda also brings the baby to areas of the visual display that are psychologically meaningful. Edges provide information about the boundaries of objects, their relation in depth, and where they can be grasped. From birth, babies show a remarkable interest in faces or face-like stimuli. Newborns, even those just a few minutes old, tend to track faces more often than other stimuli. This preference for faces is not only fascinating but also crucial to their social development. Research indicates that infants just a few hours old can already discriminate the mother's face from a stranger's. By about 3 months of age, this preference for faces or comparable non-face stimuli is clearly established. This early ability to recognize and prefer faces helps infants connect with their caregivers and begin to understand their social world. By 6 months of age, infants show different forms of brain activity when processing faces compared to other stimuli, similar to older children and adults. This indicates that their brain is already specialized for the face recognition. Interestingly, babies also show a preference for relatively attractive faces as determined by adult rating over less attractive ones. This preference is evident even in the newborn period. One possible explanation is that attractive faces are often an average or composite of many faces, which might fit better with babies' developing image of a face. Several developments in face perception occur by the second half of the first year. Infants became capable of recognizing a face as the same despite changes in expression or orientation, They can also start to classify faces based on sex, showing different reactions to male and female faces. By the age of 6 months, infants can distinguish their own face from another infant's face. They can also discriminate between individuals from different races. However, this ability changes as they grow older. From around 9 months, infants begin to show perceptual narrowing, meaning they can only discriminate individuals from their own race. This phenomenon of perceptual narrowing highlights how infants' experiences shape their ability to recognize indifferentiated stimuli. It underscores the importance of early exposure to diverse faces to maintain a broader range of facial recognition skills.